Number 49. Both fusion and fission are nuclear reactions. Why is a very high temperature required for fusion, but not for fission? Okay, good question. Now, let's just give a quick rundown on the difference between fusion and fission, right? Fusion is what happens when you have two smaller atoms coming together. So I'm just going to represent them by smaller dots. And when they come together, whoop, whoop, they produce a larger atom. This is exothermic because the energy, basically the mass that you're making as a product is always going to be less mass than what you started with. So the lost mass can't just miraculously disappear. It's got to get converted into something, and that's the energy. So that's what fusion is. It's when you have smaller atoms coming together to combine into one larger atom. Now, on the flip side, fission is the opposite. Fission is when you have a larger atom. So a larger atom, and it gets struck by some type of nuclide. Chances are, not a nuclide, but some type of particle. It's going to be, chances are, a neutron. And because of that split or that interaction, it splits into smaller atoms. And the same idea here is that your product's mass will always be smaller than what you started with. So where does that mass go? Can't just evaporate or disappear. It gets converted into energy. And that's why both of these are exothermic. Now, the main question for this question, obviously, is why do we need very high temperatures for fusion? So in this case, we need high temps. Chances are, maybe temperature, the sun temperature, but even higher temperature than that if needed. Fusion requires high temperatures versus fission, which doesn't require high temperatures. Fission is the main idea behind the Oppenheimer movie, right? The Manhattan Project and what they made, if you catch my drift, that is fission. Chances are, the large atom is going to be uranium, it's going to be plutonium, bigger atoms to release that gigantic amount of energy when it starts breaking down into their smaller atoms. So it does not require. And, it's absolutely correct, right? It doesn't require high temperatures. That's why they're so dangerous. Think of, Chernobyl as well. Yeah. But anyway, why does fusion require the high temps and this doesn't? Well, keep in mind that going back to your kinetics, right? Your kinetics chapter, if you guys have done kinetics, chances are you probably have done kinetics before this, is that higher temps speed up reactions, right? You'll have a higher reaction rate. But even more than that, right? You will have more kinetic energy. This is the key, right? Kinetic energy is the energy of motion. Higher kinetic energy, the faster the atoms are moving. Because in the formula, kinetic energy equals mass times velocity squared, the more kinetic energy you have, the higher the velocity of the atoms. And it does require a lot of kinetic energy to make sure that these smaller atoms bop right with each other to form that larger atom. So it's this idea that you need to have such high amounts of kinetic energies, such high velocities that you give yourself a chance for those smaller atoms to actually come together and fuse together. Also, you're overcoming the attractiveness or the non-attractiveness of the two nuclei, right? The nucleus of an atom is always positive. So as you come, as one atom is coming to closer to another atom, the positives are going to try to repel each other. So you need to overcome that repulsion. And that's why you need to jack that temperature up, because you want to surpass the repulsion of the charges. You want to get that velocity up. And you want to make sure that those atoms smack into each other so that it does produce a larger atom. So this whole idea, basically in a nutshell, is what's going on. So it's all about the higher kinetic energy, higher velocity of the atoms, and because of that, you can overcome the repulsion. Am I spelling this right? I guess so. Repulsion of the positive nucleus. Fission, on the other hand, since it's just one larger atom splitting into two, there is no need to, increase kinetic energy or increase the velocity. It's just going to split. It's not two atoms coming together or anything like that. It's just basically a neutron that's going to be bombarding the particle, but it's not two actual atoms. So this whole answer in a nutshell is why you do need high temperatures for fusion, but not fission, obviously. And that's it. I hope this helped. Let me know in the comments. Thank you so much for viewing the video. Subscribe to the channel if you want to help us out. Thank you so much. Like the video as well. I hope you guys are having a great day. Keep studying hard. I'm rooting for you guys on your next quiz or exam. And as always, I hope you have a great day. Keep studying hard. I'll talk to you soon. Bye-bye.